Und als nächstes Team haben wir wieder ein Team von der Universität Zielona-Góra, die uns nicht nur eine Präsentation mitgebracht haben, sondern dazu auch ein Modell. Lasst euch überraschen.
Hello everyone, we are EcoFlow from University of Zielona Góra. We are very excited to be here. Let's begin. As drones become more advanced and widely used, energy efficiency is becoming a key factor in their design and operation. This allows this analysis compares different types of drones to evaluate how they perform under changing flight conditions, such as varying altitude, wind, or mission profile. Particular attention is given to hybrid drones capable of switching between flight modes, such as vertical takeoff, landing, and fixed wind curves. This flexibility allows for the assessment of how mode transition impact overall energy comparison compared to single mode drone configuration. The objective is to determine which drone design offers the best energy performance in real-world scenarios and how hybrid system can contribute into improved efficiency and reduced environmental impact.
So before we dive into the energy analysis, let's take a quick look at the three main drone types, each with its own strengths and trade-offs. So first we have multi-rotors that are perfect for tasks that require stability and hovering, like inspections or flying in tight spaces. But they use a lot of energy because all the rotors must stay active to keep the drone in the air. Next we have fixed wing drones that are much more efficient for long distances, and they basically work like airplane. They use aerodynamic lift instead of constant motor lift thrust, but they can't hover and need a proper launch or runway, which limits flexibility. Then we have hybrid VTOLs, the most versatile option. They can take off vertically, then transition into much more efficient forward flight. But that flexibility adds complexity. The transition phase, switching from vertical to forward flight, horizontal, turns out to be the most energy-intensive part of the mission.
So the true test of performance occurs under variable and demanding conditions, especially in the face of wind and heavy payloads. Multi-rotors spend their energy fighting the wind instead of performing the mission. With 9 meters of headwind, a multi-rotor energy consumption can increase 5-fold, making operations impractical. For a multi-rotor, every extra gram counts. Adding a heavy LiDAR sensor can reduce flight time by up to 40 or even 50%, while for fixed wing, impact is minimal. Next.
This slide shows a key inside. In hybrid drones, the transition phase is where the most energy is lost, more than even vertical takeoff or hovering, which are already quite demanding. But there is an interesting part. We can, with better software based on control system, we can reduce the energy cost of this phase by around 30%. That's what the pie chart shows. A significant chunk of waste energy can be recovered without changing the drone physical design. This highlights a bigger shift in drone technology. Software is now just as important, if not more, than hardware.
So this is comparison of all types of drones. Here we have in the table the average range, speed, endurance, and CO2 emissions. And after a quick look on the table, you can easily say that the Stallion construction has 240 kilometers of range and endurance, and it outperforms other types of drones. Despite the lower average speed, it maintains exceptional energy efficiency, less than fixed wing and multi-rotors. And this makes the Stallion not only more operationally effective, but also far more friendly to environment and due to low carbon footprint that he makes.
So, and at the end, we have a slide with compared design for wind turbine inspection. We have few categories. Transit efficiency. So, on the energy plant like this, we have a long distance between turbines. So, by the aerodynamic design, you can save a lot of energy using the wings and so we can save a lot of energy with aerodynamic forces. Next category is close-up inspection. As we know, to watch something, it's better to looking at it with the same place. So, VTOL hybrid VTOL drones give us the same result as multi-rotor drones, but with more energy saves. High wind resistance. Multi-rotor drones have problem with strong wind. So,
20 seconds.
with aerodynamics shape, we can reduce this danger.
Thank you so much.
Thank you for the presentation. First question that comes to mind is, what is the fixed wing drone that you're holding? Was it made prior to the competition? And what kind of special purpose does it serve?
Yeah, this drone is called Stallion. It's a Polish project that we are adapting for our use at our students' club called Lotus. We are trying to use it as a platform for different tasks and purposes, like, for example, mounting maybe a LiDAR or thermal cameras for fire searches, and it is a VTOL start hybrid, and it's also the construction is also 3D printed, And
I see. So it's made by the student club or others, and prior to the start of the hackathon, but you're using like a LiDAR sensors on it. What are you purposing the LiDAR sensors for example?
we are using them for 3D scans of maybe not yet, but we want to use them for 3D scans of ground and forests, and yeah, something like this. Okay.
Okay, from my side, to produce such drone, what is the cost of materials?
For the 3D filament, it's around 120 zloty, but we want to use aero PLA euro. Ile on kosztuje? Tutaj? Okay. Ile on it's around 3,000 zloty, or I would say 700 euro. Yeah.
I have a short question about, you show in your charts that you can have a better efficiency for, let's say, range and energy consumption and so on. Your approach comes also with an additional weight because you need some mechanics and so on in order to provide these two phases of hovering and also to normal flight mode. So what kind of additional weight would you need to put into the planes to realize your approach?
Yeah, so the whole drone is going to weigh around maybe 3.5 kilo without the sensor or different camera modes. So yeah, it will be pretty light, and we may need. I don't know what to say. What else to say.
Okay, thank you for the Q&A session, and we will move forward with the next team. Thank you again for your.
Thank you very much.